Good morning, dear students. We shall now study oxidation concept. Oxidation concept can be studied by two processes. One is a classical concept and the other is a modern concept. First of all, we shall study classical concept. In the classical concept, oxidation can be defined as a process which involves five things. First one is addition of oxygen. That is, now we shall take example carbon plus oxygen. This is oxygen. The definition says addition of oxygen. Now here is the carbon. O2 has been added to carbon to form CO2. We shall say that carbon has been oxidized to carbon dioxide. So here is a addition of oxygen. Oxygen added to C, we get CO2. Here also, oxygen added to sulfur, we get sulfur dioxide. We say sulfur has been oxidized to sulfur dioxide because oxygen has been added to sulfur. Next, this is a magnesium atom. Now, magnesium when burns in oxygen, magnesium oxide is formed. We say here oxygen has been added to magnesium. Therefore, magnesium is oxidized to magnesium oxide. Now come towards the second definition of oxidation, addition of electronegative element. Electronegative, since oxygen is negative, therefore this is an element, we have written addition of electronegative element. Now, addition of here chlorine, that is chloride, is a electronegative element. Here it is H2S. Now, addition of Cl to hydrogen has taken place. We get HCl, hydrochloric acid, and sulfur is removed. We say in this case electronegative element chlorine has been added to hydrogen of H2S to give you HCl. Similarly, sulfur is an electronegative element. Now when zinc is heated with sulfur, then the electronegative element sulfur is added to zinc to form zinc sulfide. Hence, it is also an oxidation reaction. Third, removal of hydrogen. Here is a reaction H2S plus chlorine give rise to 2HCl. A removal means hydrogen has been removed from H2S, and when hydrogen is removed from H2S, sulfur is left behind. This is the sulfur, and hydrogen and chlorine combine to give 2HCl. We shall say now here that in this process chlorine is an oxidant and it has removed hydrogen from H2S to form H. Similarly, 2Hi plus ozone. Here again, what we see, removal of hydrogen. Hydrogen from iodine has been removed and iodine is left behind as Hi2. Therefore, H and O3 combine together to give you water and oxygen. Here again, ozone, O3 is an oxidant and it has oxidized Hi to iodine. Fourth, removal of electropositive element. Hydrogen is positive, therefore we usually call it electropositive element. Here is an example, potassium bromide plus chlorine give rise to 2KCl plus bromine. Now, electropositive, here you see out of KBr, K is positive, Br is negative. Therefore, what we see, the K has been removed from Br negative to form KCl and bromine is formed. Now, bromine, this K plus is now removed. Similarly, in this case, K4, FeCl, say potassium ferrocyanide, where hydrogen peroxide gives us potassium ferricyanide and KOH. Here again, there are 4 K positive, and here we are left with the 3K positive. It means 1K has been removed. Therefore, it is also an oxidation process. Lastly, in an oxidation process, there is always an increase in the valency of an element. Here is a ferrous chloride. Ferrous chloride. The valency of Ferrous is 2. How to know it? This is 2. That by crisscross method, we always come to know the valency of an element. Here is an iron 1 and here are 2. Therefore, the valency of Ferrous is this one, 2. Now, when it reacts with chlorine, we get 2 ferric chloride. Here, the valency of ferric is 3. This is 3. This is 3. Now, increase 2 to 3. It means that the valency of iron has increased from 2 to 3, hence it is an oxidation process. Thank you for watching.